You guys, we're going through problem number 18 from Webwork number 16. Going to be focusing on finding the eigenvalues and eigenvectors for this matrix here. And then we're going to solve that system of differential equations with the initial conditions that we see here. So when I get a problem like this, I always start by splitting up the initial matrix. It helps me get a better understanding what's going on. It's definitely not necessary, but it's just how I like to visualize it. From there, we get our first matrix used to solve for the eigenvalues. And remember, you're always multiplying through on the diagonal with these. So multiply through on the first diagonal, and you get what you see there. And then you multiply through on the second diagonal, and that's subtracted from the first product. That's why we have the negative symbol there, but our second product's 0, so it doesn't really matter. And you can see we have a very solvable equation here. We're going to set this to equal to each one of these equal to 0, and we get our first eigenvalue is equal to -1, and our second eigenvalue is equal to 5. And now we are going to set up again to find our eigenvectors. We're going to be using this equation here. Don't forget that I is the identity matrix. So I is equal to 1, 0, 0, 1. Easy to forget. You get stuck at this part. And A comes from our coefficient matrix up here. So after that little refresher, we can go into solving these and do some row algebra and arrive here. And sometimes it's a little easier to see by writing it out like this. Again, it's an extra step that I take because you could just solve this right from here, but I like to take the extra step and write it out with x and y in there. It just helps me ensure that I'm not going to make any mistakes. And from this, we can see that x can equal anything, and it'll be 0 because the coefficient associated with it is 0. So when that's the case, I'm always just going to pick a 1 because it's easiest. And to get this 6 to equal 0 in both cases, the only coefficient that would do that is 0. So from that, we arrive at the first eigenvector of 1, 0. We're going to repeat that process again with the row algebra through the matrices, and we arrive here. This is a little bit more familiar to us. We have the bottom row zeroed out, and the top row has some coefficients to work with. So if you set this top row equal to 0, pretty easily see that we end up with 6y equal to 6x, and that is equal to y equals x. So x and y can equal anything. And again, when that's the case, when they could equal anything, I'm always just going to pick 1 to keep things simple. And we end up at our second eigenvector here. So once we have our eigenvalues and eigenvectors all sorted out, then we can shift gears and actually start finding a general solution. And our general solution for these problems takes the form of this here. Lambda 1t times v1 plus c2 e lambda 2 v2. So after that, we're just going to plug in, and this goes pretty smooth. So plug our lambda 1 in here, get the -1t. Plug our lambda 1 in here, get the -1t. Lambda 2 in here, get the 5t. on our e functions there, and we multiply in for x of 1. We're multiplying to the top value and our eigen matrices, or our eigen vector matrices, and we end up with x1 here. And then same thing for x2, multiply it to the bottom number for eigenvectors, and we get our second equation here. And now the initial values were pretty easy on us. We're going to plug 0 in for t, so that's going to get rid of our e in both equations, and then we're just working with the undetermined coefficients and simple system of equations to solve here. You're going to plug in, x2 gives us a value for c2 right off the bat, and then I'm going to plug that back into my equation for x1 and solve those. And then once I get my values for c1 and c2, plugging that back into our general solution to find our particular solution there. So I guess the hardest thing for this would be just the matrix algebra, since that's kind of a new concept, at least for me. I haven't taken any classes that really focus on much matrix math. So figuring out this process here definitely took me the most time. But after that, everything down here, other than this formula, is very similar to what we've been working on, throughout the entirety of the course. So I hope some of the tips and tricks in this video help you for exam 3, and thanks for watching.